Hi, hello, good morning, one and all. Welcome to the session. Can anybody confirm about audio and video? Please do let me know about audio and video. Can anybody confirm about audio and video? Is this audio and video both are clear? Hi, guys. Let me check from my side. If everything going well, then we will start the session. I think it seems it is going on. Somebody can confirm about audio and video. Okay, chalo. All right. All right. So welcome to BYJU'S exam prep. Those who are preparing for GATE and engineering service examination. So this session will be helpful for them, especially those who are preparing for GATE and engineering service examination. So in this session, I am going to discuss about the PMMC operation and the internal parts. So I have a PMMC instrument. So I try to dismantle it. Just give me a second. If anybody has any sound issues, please do let me know, and so that we can move on. All right. So what I was trying to say is this session is useful for the aspirants, those who are preparing for GATE and engineering service examination. Okay. So here I am going to discuss about some construction details and then operation. Okay, so I'll show you the practical meter here, the actual meter. I actually dismantled it, so the internal construction I'll try to show you. I'll try to put in front of you. Before that, the images what we got in the textbook or otherwise maybe in the internet, so you can see that and try to find the difference between the images we get in the internet and actual the practical meter construction. Okay, so that you'll get an idea, and then we will move on to the questions part. After this session will end up at 11:45 a.m. Okay, so after 11:45, now at from 11:45 we will be taking some quizzes on app. We will be taking some quizzes on app. The link for the app, it will be provided very soon at the end of this session, and you can join from that link. Okay, all right. So welcome everyone once again. So we will move on to the session. Before moving on to the session, there's a small introduction about myself. My name is Naveen Gollapalli. I have 11 plus years of experience in teaching. Most of the times I'll be teaching circuits, machines, measurements and power systems. Okay, so I did my masters in electrical power system from JNTU Hyderabad. I cracked GATE and State Public Service Commission examination. I taught more than 20,000 students since 2012. So there's a small introduction about myself. And those who are preparing for GATE, here is one scholarship test which is going to be held on 25th June at 9 a.m. So please try to register for this to get the discount up to 90%. If you are if you have any financial assistance, if you want any financial assistance, I think this is the best way to get the discount or concession on the GATE fees. Okay, all right. Moving on to the next one. So here is one more workshop which is going to be conducted from the BYJU'S exam prep platform, and this is going to be held on 27th June, and the timings is 7:30 p.m. Okay, so Richa madam is going to take up this session, and she will be discussing about the strategy to crack the GATE examination. Okay, whatever the strategy she is going to explain for GATE, that I think I'm damn sure that will also help to crack the engineering service examination also, right? So moving on to the today's session, let me show you some image here in front of you. Whatever the image we have got here, so this is my permanent magnet. So I have a north pole and I have a south pole. Now between the permanent magnet you can see here the aluminum former, and that on the aluminum former there is a copper coil, and this entire arrangement is placed on a spindle like this. This is a spindle. Okay, now on the top of the aluminum former you can find a spring. You can find a spring at the top and bottom, and of course after that we have a pointer. Right. So this is like what I can say is, this is like, so whenever you give the supply to the springs, you take the terminals outside and you give the supply to the springs. This supply voltage is going to drive the current, and the current flows through the springs and enters into the coil, and of course the current also tries to flow through the coil, and the current leaves from the spring like this. So that is how the circuit is going to be completed, and the current is going to be circulated. We have a permanent magnet, so because of permanent magnet we will be having magnetic flux lines like this between north pole and south pole. And now what we are doing, we are placing a current carrying conductor. Let me show you. It's a turn, so turn is nothing but two conductors. So I am not showing you so many turns. There are so many turns, so I just wanted to show you one conductor, the conductor from these turns, and from the conductor from these bunch of conductors. So from this bunch of conductors I just wanted to pick one conductor. From the bunch of this conductor, this side conductors, I just wanted to pick one conductor. So I have one conductor here and I have one conductor here. So because of voltage source, and this current may be under one point in one conductor it could be a cross mark, and in another conductor it could be a dot mark. And due to this current carrying conductors, you will get a flux, and that flux can be flux direction can be found by applying right hand thumb rule. So if the current is going into the conductor, the flux will be clockwise. If the current is coming out of the conductor, the flux will be anti-clockwise. So cross mark is indicating current is going into the conductor, so it is clockwise, and dot mark is going to indicate current comes out of the conductor, so it is going to produce anti-clockwise. And due to this reason, we have current carrying conductor, we have permanent magnetic field, and the current carrying conductor is producing one more flux. So ultimately we got two flux lines, and these two flux lines, between these two flux lines you will get a reaction. Of course, maybe the fluxes can aid at one point, maybe fluxes can oppose at other point, and due to which a force tries to be induced on the conductor. Why only on the conductor? Why not on permanent magnet? Because permanent magnet is fixed, and whereas a conductor is free to rotate. So force can be, we can experience a force, or we can feel the force, or we can see the force on a moving system or a free body. Okay, so permanent magnets are stationary, whereas the conductors are free to move. So that's the reason why you can get a force, you can see a force, or you can observe a force on the moving conductors, or on the conductors. So the force can be found by applying Fleming's left hand rule. So if this forefinger is going to indicate the flux direction, and thumb finger is going to indicate the force direction. Of course, the middle finger indicates the current direction. So current is going in, so middle finger is into the conductor, and north pole to south pole, so the forefinger is flux direction, and therefore the force produced by this cross mark conductor is going to be downward, and the force produced by the dot mark conductor is going to be, you see, flux direction is same, but current is outward, current is coming out. So I should show this middle finger out of the conductor, and therefore the force is going to be upward. The thumb will be upward. So thumb direction is going to be the force direction. Now here is the force, and this force tries to move the conductor over a particular distance, and that is what we call it as twisting moment of force. So the electromagnetic torque is going to be produced in the anti-clockwise direction. Okay, that means what, the spindle tries to rotate in the anti-clockwise direction. If you are expecting a clockwise movement, and this must be a dot and this must be a cross, therefore you can expect the flux direction, you can expect the force direction in the what I can say, in the in the clockwise direction. If this is dot mark and if this is cross mark, then the force will be here downward, here the force will be upward, and the electromagnetic torque direction will be clockwise. And hence the spindle tries to move in the clockwise direction. The pointer attached to the spindle also moves in the clockwise direction, and therefore you will get a force, that is what deflection force, and the pointer tries to move from one place to another place. This is what PMMC operation. It is same as DC motor operation. PMMC operation and DC motor operation is no more different. The only thing is we will be having over there commutator. We will be having commutator, not just DC motor. Why I am saying DC motor? Because I have DC supply. That's the reason why I am comparing with DC motor. Otherwise I can compare with AC motor also. It's a motoring mode operation. Completely it's a motoring mode operation. Okay. Now the point is here, to stop the pointer at one location, we need a control force. That control force will be provided with the springs. So when TD and TC are equal, then we will get a steady state. So this is a simple operation of PMMC meter. Okay. Now if you want another force, that is if the pointer is swinging, if the pointer is moving, if the pointer is making some fine oscillations, then eddy current damping comes into picture, or eddy current damping force comes into picture, and it will damp the oscillations. It will damp the oscillations so that you can take the reading easily without any deviations at all. So that's the that's the idea behind the PMMC operation. Okay, so let me show you the internal construction, the practical meter internal construction. Okay, so this is my permanent magnet and this is my aluminum former, right? Okay, so between the permanent magnets I just place the aluminum former, and the construction, when it comes to the construction, it quite reverse. You see, if you want, so that you'll understand. So this is my permanent magnet. This is my permanent magnet. Okay, so here is also permanent magnet. So this is a support. So what I will take up this is, so this permanent magnet, I will take up this support and I will insert in the aluminum former. So generally the aluminum former will be like this, and on this we will be having a coil. Okay, now here I am going to place the permanent magnet, and the support will be like this. So these supports are there, no? This support will be like this. So you are going to place like this. So like this. So if this is aluminum former, we are going to place like this. Let me show you. Let me show you in another picture. You see, there is a dot. So there is a hole. There is a hole here, and there is a hole here. So in that hole, we are going to fix that permanent magnet like this, and we have an aluminum former here. What is this black body? This black body is going to be the low resistance, low reluctance path. Low reluctance path. Because we have a permanent magnet here. We have a permanent magnet here, and the permanent magnet is going to establish a flux lines through the low reluctance body. So this is a low reluctance body. Right, flux is established. Now we have a flux lines, and we are going to place the aluminum former like this. Now the aluminum former is going, on that aluminum former we have conductors. Now the conductor is going to cut the flux lines. Obviously the permanent magnetic flux lines will definitely link with the the aluminum former conductors. So far we have got only one flux, and now see, these are the terminals. These are the terminals where you can give the DC supply. If you give the DC supply, now the current flows. The current is entering through this body. So here is the spring. You see, here is the spring, and the current enters into the coil, and of course the current circulates in the coil and comes out from the bottom spring like this. So if you want to see the aluminum former and the spring structure, let me separate it. Let me separate it. I just removed it, entire structure. You see, this is the bottom portion or top portion, and I have a spring, and then I have a coil, and again I have a spring. So on the top of the former, aluminum former, I have a pointer, and this is connected with the supply leads. So this is where we will give the supply, positive and negative supply, and due to that a current flows. The current flows through the current carrying conductor and comes out like this. Now what we are going to do is, this permanent magnet we should keep here. keeping here is nothing but we should keep here. So the entire arrangement has to be placed, has to be inserted here. Now the permanent magnetic flux lines and the electromagnetic flux lines, or otherwise electromagnetic field produced by the current carrying conductor, they will interact and create a force, and that force moves the pointer over a certain distance. When the pointer moves over a certain distance, the springs also will compress, and due to that compressing action of the springs, you will get a control torque. When TC and when controlling torque and deflection torque are equal and opposite, the pointer stays at one position. The pointer stays at one position. If it makes fine oscillations, then the eddy current damping comes into picture, and it will suppress the oscillations. Okay, so that is what the operation of the PMMC instrument. If anybody has doubt, please do let me know, so that we will move on to the quiz part. What is the time? It's 11:34, so we have another 10 minutes. If you have any doubts, please ask me. So I just wanted to repeat that this session will continue on BEP app.